Welcome back. Today we're going to go over just a quick review of this study guide. I'm going to do one problem from each section for the most part. But starting out, this first section is whether or not you can add or subtract linear expressions with rational coefficients. So what that basically stands for is that we're going to separate out our terms and we're going to combine like terms. So on number 1 here, I go ahead and separate it by putting something in between the plus and minus signs for everyone that shows up. So I have 3 terms here. I then combine like terms. This is the only one with a variable, so that means that it doesn't have any like terms, whereas these two don't have a variable, so they have to be like terms. So I go ahead and just combine like terms. -8 plus 8 gives me 0. And then if I were to bring down the 9p, I would have 9p plus 0, or 9p. All right, next type. I can factor and expand, meaning distribute, linear expressions with rational coefficients. So starting out on this one, anytime we distribute, we circle the number and the sign out in front, and then we draw arrows to the problem and multiply. So 2.5 times r, 2.5 times r, and then minus 2.5 times 5. So minus 2.5 times 5. And when I combine those, I go ahead and get 2.5r. And 2.5 times 5 gives me 12.5. So this problem up here is identical to 2.5r minus 12.5. Now the opposite of distribution is factoring. So distribution puts everything back together. Factoring takes it apart. So we're going to go from this answer back to the very beginning one here. But I'm going to go ahead and try it on number 11. To do that, I need to know 2 things. So I take the numbers that are listed. So I have -6 and -15, or 6 and 15. And I'm going to find the greatest common factor of 6 and 15, which the greatest common factor is 3. And the reason we know that, the factors of 6 are 2 and 3, and the factors of 15 are 3 and 5. They both share a 3, so the greatest common factor here is 3. So I go ahead and use that, and instead of writing this problem, I'm going to write a 3 in front, and then I'm going to ask myself the question, what times 3 gives me -6b? Well, if I want -6, I'm going to have to times by a negative, so that'll be a -2b. And this one's already a minus, so I'm going to leave it minus. And then 3 times what is 15? Well, that would be 3 times 5. So these two problems are identical. This one, I factored out a 3 and got -2b minus 5. Now, a lot of times we actually don't want to have the variable here with a negative. So instead of factoring out a 3, I could also factor out a -3, which means everything on the inside is just going to flip, and not flip, but flip their sign. So that's going to be a +2 and a +5. So I changed that, +2b plus 5. All right, next type. I can rewrite expressions in different forms. So if I look at this one, the very first thing we need to do is we need to analyze the problem and see what needs to be done. So I'm going to go ahead and take number 14, and I notice that this -1/2 or -1/2 is out in front of parentheses. So order of operations states that I have to follow through and answer this by doing order of operations, but there's variables in the problem, so I can't follow order of operations. I then either have to distribute or I have to combine like terms. In this case, because there's parentheses, I have to distribute. So I'm going to go take this -1/2 and I'm going to distribute it to both the 4y and the -16. So I draw my 2 arrows there, and then I just ask what's half of 4 and make it negative. So from there, half of 4 is 2, negative, and then half of 16 is 8, and I made it negative. And I bring down this one that I don't do anything with yet, so I bring down the 8y, and then I can go ahead and separate out my terms. I would draw my lines here and have that separated out, and I notice this one has a y, that one has a y, so 8 minus 2 would give me 6y. And then right here, minus negative, that's the same thing as saying plus, so that's going to be +8. Okay, next type. I can solve 1- and 2-step mathematical problems. So with this one, I always like to keep it organized, step 1. And I go through and I look at my problem and I find the side with a variable. And then from there, I say the opposite operations here. I have a negative 5 here, and that's multiplication. Any number next to a letter means multiplication. And then I have a plus 9. Well, order of operations says I have to do multiplication first, then addition. But if I do order of operations backwards, I have to do this addition first, then the multiplication. So to get rid of addition, I go ahead and minus 9 from both sides. I then rewrite the left side, which would be negative 5x. 24 minus 9 will give me 15. I then, opposite operation, this is times negative 5. I'm going to go ahead and divide by negative 5. Whatever I do to one side of the equation, I have to do to the other. And I would get negative 15 divided by negative 5. The negative 5's cancel on the left, and I'm left with x equals negative 3. Okay, next section. I can solve multi-step mathematical problems. Same thing on this one. You're going to go ahead and follow the steps to solve here by undoing them. And I'm going to go ahead and start with this one right here on number 24. We circle the number and sign outside of the parentheses, and we start with distribution. Now, there is another way to do it. If you don't want to distribute, you could get rid of this times 1/2 by dividing both sides by 1/2. But I'll show you that on another step. For this one, I'm going to go ahead and distribute that 1/2. Half of 6 is 3. Half of 2 is 1. So I'm going to have 3g plus 1 equals 12. And then I do the same thing I just did. I draw my line to keep it organized. The opposite operations here, I subtract 1 from both sides. I then rewrite my problem, 3g equals 11. And then from there, I do the opposite operation and divide by 3 on both sides. So my final answer here, g equals 11/3, or 3 2/3. I'm going to leave it as an improper fraction, though. Next question. On this one, I'm going to go ahead and walk through just kind of how to find a variable and then set up an equation. To do that, I have to identify important pieces for story problems. So in this one, I can use variables to represent quantities and write equations. So it's not that we can solve this one. I just need to be able to write a variable and write an equation there. So with this information, it says the home improvement store advertises 60 square feet of flooring for $287, including $80 installation fee. So we need to write an equation that would represent the cost of 1 square foot of flooring. So if I do that, I go ahead and start by identifying the key pieces of information. 60 square feet of flooring is important. The $287, that's the total amount, and it includes an $80 installation fee. So I take that information, and I'm going to go ahead and start identifying what my variable is. In this case, I want to know the cost of 1 square foot. So I'm going to say cost is equal to x there. So that 1 square foot cost is x. And then in my equation, I know that if I add the two values together, I could get total cost. So in this case, if I say 60 times the square feet, times the cost, because 60 is the square feet. So square feet times cost, I add that to an installation fee, and that should give me a grand total of 287. And this is all I need to do, because in this section, it just says I can write the equation. I don't have to solve. In the next section, we'd have to solve. And so it's really important that we get that done. All right, so next section. Now looking at this one, I'm going to go ahead and do number 34 because it's the more difficult of the two shown. It says here 5 sisters each bought matching scarves, 2 pairs of socks. The scarves were priced at $12. If the total bill for all 5 sisters was $125, what was the price of 1 pair of socks? So this is kind of a loaded question. There's several pieces that if you're not paying attention, you'll miss. But it says that these sisters, they're going to the store, they're buying a scarf and 2 pairs of socks. And it says specifically that all 5 of them bought matching scarves and socks. So if that were the case, I have to set up my problem, and I can set this up pretty easy. I'm going to identify a couple of things here. And the very first thing is that there are 5 sisters, and there's 1 scarf and 2 socks, 2 pairs of socks that were being purchased. The scarves are at $12. The total bill is $125. So if I look at this here, I can say scarves plus socks equals total cost. Now there's a problem with this. The problem is this is one scarf, and this is one sister that bought 2 pairs of socks. But it says here 5 sisters bought those. So what I have to do to this problem is I have to go ahead and take this one purchase here of 1 scarf and the 2 pairs of socks. I have to multiply that by 5 to account for all 5 sisters. Now the nice thing about distribution is, especially when we have it in an equation, I don't have to distribute. If there's nothing else in this problem other than the distribution and this stuff right here, then I can go ahead and get rid of this distribution because that's 5 times a number. I don't know what this number is inside here because there's lots of stuff, but it's 5 times that number. So instead of doing distribution and then making my problem bigger, I'm going to go ahead and just get rid of the distribution by doing the opposite of 5 times something. It's going to be divided by 5. So I divide both sides by 5. The 5's cancel. I'm left with 12 plus 2s equals 25. And then from there, you can see this is the exact same type of setup. We have $12 for the scarf, 2 socks, but whatever that cost of the sock is, I don't know yet. So I do the order of operations backwards. I minus 12 from both sides. And then I'm going to go ahead and divide both sides by 2. Now 13 doesn't divide evenly by 2, but it does make a nice decimal. So we would get the cost for the 1 pair of socks is $6.50. So we know that the socks here, each pair of socks is $6.50, and that would add up to the $125 that the sisters spent on their trip. Okay, I hope this was helpful for you. If you have any questions, please let me know, and have a great day.